everybody in LA. I'm Jim Hudspeth. I'd like to introduce Marvin Houston and Dan Custer.
Hello. During the presentation, if you have any questions, you can email questions at read-electric.com or text 775-433-9390.
So today, basically, what we're going to talk about is spherical roller bearings, doing the Endplay adjustments. I'm also going to discuss some of the stuff that we're seeing a problem with as far as oil leaking on the same kind of motors. You can see on the screen that we're bringing up spherical roller bearing application, and basically they're designed for extra high thrust capacity. Didn't you have a question about any of this?
Yeah, my question is, if you have a ball angular contact bearing, when should you convert it over to a spherical bearing?
That's a good question, and it's based on the manufacturer. So if Tim is buying a motor for a customer, he's going to ask them what thrust capacity they need. So a standard motor with one bearing would be considered 100% thrust. Two bearings in the same motor would be considered 175% of extra high thrust. A spherical roller bearing in that same motor would be 300% of extra high thrust. So it kind of gives you a better idea. Modifying motors to accept a spherical isn't as easy as it sounds. I mean, it can be done. We've done that with the 800s for Heber. We've done it for other customers where we've increased the size of the bearing mount to accept it, and we've also expanded the housing to have it fit in. There's a limit to how far you can go. We've done some of this in the past on smaller 500-600 horsepower motors that they kept adding weights to the well, and they started getting fracture marks inside the upper bracket around where the bearing mount was. So if it had continued like that, sooner or later the bearing would be down at the bottom of the motor. Okay. And again, the spherical roller bearing is pretty much, besides having a Kingsbury, the strongest bearing that you can use for a real large amount of down thrust. You can get these in spring load and without spring load. On the spherical, you want to use a 68 oil for anything up to 40 degrees. After 40 degrees Fahrenheit, you want to use a 150. So the only time you're going to use a 68 is typically in the winter time. Like up here this morning, it was 22 degrees. So a motor up here, you'd want to use the 68 during the winter months. If you've got a motor that's fully loaded, full capacity, and is a 1.0 service factor, and the motor's going to run extremely warm just out of the box, you could probably get away with the 150 in it then. To give you another example real quick while I'm thinking about it, we had a customer in Fallon. He was using 220 mobile instead of the 150 weight, and it coked, meaning it turned the oil cooling tubes that were nice shiny stainless to a black coating that you could take a knife and scrape it and would carbon coming off of the tubes. So it got so hot it wouldn't dissipate the heat anymore. So we ended up getting them to go back to the 150, and they pretty much solved their problem with that.
That can also cause issues with the paint peeling off too.
Oh, absolutely.
And
you get the paint in the
the
housing to
rollers.
start getting so hot that it starts peeling up, getting into your roller bearing. You know what's going to happen then. Before we get into too much of the Endplay setting portion of it, I wanted to kind of go over this. This is a GE vertical that you're looking at. The lower bearing is up in the lathe, and what we're doing is we're machining out the shaft to put a steady bushing in. But before we go there, I just want to explain that the hole closest to the bearing is where the oil tube is going inside the shaft, and it should stick up above that first hole. The theory is that as the shaft rotates with the oil tube inside of the shaft, the wall thickness is really, really thin. So between the oil tube and the shaft itself might be 50, 60 thousandths, just say. It's very easy for the oil to whip around inside of that and start climbing and try to go over the oil tube and out onto the ground. So what they're doing is they're putting that vent right there so that as the oil climbs, it hits those two holes and it spins it out back into the bearing chamber. Okay. The second hole is up higher, closer to the shoulder. That hole is for the bearing cap. When you're looking at the bearing cap on these, they have large standoffs that actually touch the outer race of the bearing. In the center of the bearing cap, they have a valley area that's machined out in the cap or casted in the cap. And the theory is that as the motor has any vacuum being formed by the fins rotating around the outside of the bearing cap, it's trying to suck oil out of the bearing cap. It's going to actually suck air through the hole. And the bearing cap should have that large cutout that covers a hole in the end bracket that goes straight out to the outside of the motor so that it can take fresh air in instead of having the oil try to pull out of the housing. One of the problems with it is that if we're putting a steady bushing in, you need to make sure that your steady bushing is above the two holes. You put the steady bushing in, and that's fine. And then I'm assuming you're going to think, okay, I'll just drill 2 holes back through the steady bushing. Well, when you put a head shaft down in there, and your tolerance is 3 to 5 thousandths, 3 thousandths is what you're looking for, you're not going to get any air through there. So you're going to reproduce the oil leak. So if you look at this picture, I put a screwdriver in that hole to show that the shaft is actually machined further back in now, so that we can put the steady bushing above both of those holes. We've been seeing a lot of the lower brackets come in saturated the hell out of with oil, and this is part of the problem. So I'm sure you've seen it or may have. I don't know if you've found the same thing or not, but this is why I'm showing you this, okay? So you get a better idea that if you've got a lower bracket that's puking oil out of it, there's most likely a problem where we're talking about right here. Now another one. When it comes to the bearing cap right there, you guys know that those standoffs on the bearing cap touch the outer race of the bearing when you're setting the end plate. About 10 years ago, maybe 15, US put out a whole bunch of their motors with those standoffs like this. One long, one short, maybe 10, 15 thousandths variance in those caps, okay? So where I'm going with that is we have the machinist here take a depth gauge and take a measure from the top of the finger down to the face where the O-ring is at in that picture. So it's flat right there. And they measure all 3 or 4 of the standoffs to make sure they're all the same. If they're not, set up the cap and make sure you clean those up and then clean the face the same amount you took off the fingertips. The reason for that is that when you're setting the end play, let's say there's a 10 thousandths difference in the fingers, the bearing is going to cock. You're going to have one finger long and short over here. So what happens is you're taking the internal clearance in a bearing and you're going to cock it inside there. And we found a lot of them. I mean, it's surprising when you start looking for them what you see.
And then another thing you want to do is don't use that bearing cap as a slide hammer to knock the bearing off.
Absolutely.
We've in the past broken some of the ears off, or you can again crack the cap in half. And then on some of the newer US vertical motors, the locking nut on the very bottom of that bearing will have a total of 4 set screws 45 degrees apart from each other. So make sure you take those 4 out, tap the nut a little bit, and then warm it up with a torch so you don't damage all the threads, which will give the machinist extra time trying to clean all those threads up.
Another thing you can probably find out down there too is that, let's use a US motor now. They use a metering plate in the bottom bracket, and you've seen them where you just pick it up and take it out. If you ever look at them and you see them bowed, that's a problem. They've got to be flat where the bearing has that setting right there. A lot of this happens when you're putting the rotor down and building the motor. You have the lower bracket on the pump base table, and you bring your rotor down in the housing with the bearing on it, and then you let go of it. And what's happening is the bearing's going all the way down to the bottom of the shoulder, but you've got this big lock nut and washer assembly that hits the metering plate. The weight of the rotor is great enough, and these things are made out of most of the time aluminum. So they bow and they crack, and you'll see cracks in these damn things, okay? So it's best if you put the jack back underneath the shaft when you're assembling it, jack the shaft up so it's right there and taking the weight of the rotor up enough to make it so that that nut and washer assembly isn't taking out the metering plate. These are drawings that we're going to just go over fairly quick just to show you that these are right out of the ESA book, so you can see them in the ESA manual, the tech manual, showing a spherical roller bearing that you have right there. There's a couple of things you can do when you're setting the end play. Let's say that you took the top bracket all by itself, stuck the outer race of the spherical roller bearing in the bracket. So the springs are right under the outer race in this photo. You can now go to the housing with a depth gauge and measure to the top of the bottom half of the bearing. You don't have the springs in it. So now put the springs in it, and when you're setting the end play, if you set it for 10 thou, the reading you first took should be no more than 10 thousandths larger in the number that you get. That's going to tell you that you got 10 thousandths exactly the same when you've used your jack upstairs, the bar across the top when you're done and everything. It's just another way to let you know that you've got the right Endplay setting. So you can check it with the depth gauge from the housing to the top of the bottom end. And that's right over there at the roller where the arrows are in this picture right now. You can see it real well. So right there, that small 1/4 inch gap to the housing, right to the left, and you can see you can get that measurement. So it'll only be whatever the Endplay setting is different when you take the second reading. Now at that time, you still have to have the top open to do it. We're finding out up here that it's pretty tough if you don't put the seal cover, and that's the large cover that goes on top of the end bell that has all the small bolts in it, basically keeping the oil from slinging out of it, that these housings flex. So when you've got a dial indicator sitting on your bearing carrier and you're trying to set your Endplay, you can get numbers all over the place because the ears are going like this and the whole casting is moving on you. When we put the seal plate in, we don't have to put the glue on it or anything else. You're only doing it for the Endplay, and you throw some bolts in it real quick, it stops doing that. It still may do some, but it's nowhere near as bad. So it's recommended to put seal cover back on it. Take your measurements with that on because you won't get as many false readings. This is the lower end. All right, just a standard, lower end bearing. You can see the black line. I want you to pay attention to that because the next photo I think is going to be more interesting to see. The black line is the oil tube. The part outside of the oil tube is the shaft. Okay, so in this picture right now, you notice that there's a hole on both sides of the shaft with a dotted line going through it, and the oil tube in this photo is in the center of that line. That black oil tube should be higher than those two holes, so that if the oil migrates up the oil tube in between the shaft spinning around the oil tube, it slings the oil back out into the housing through those two holes. So we've got a lot of oil leakers that come in here and find out that that oil tube is below the hole. It's never going to fix it. So we have to increase the length of the oil tube, plug the hole and re-drill the holes. I mean, there's certain things to do, but changing the oil tube is probably the best, just to increase the length. And that could be because somebody's already taken the oil tube out, stuck a weld across the top with a key stock and drove it out or pressed it out. Now you clean up the tube and the tube goes whoop a little smaller, and now you got the oil leak problem.
And if you're going to increase that tube, make sure you're not going to hit the shoulder on the inside of the rotor. You might have to do a little bit of machine work on the inside. That way there's no rubbing.
The reason Marvin's saying that is that it's pretty tough sometimes to find the same oil tube material. So what you'll find is an oil tube that has maybe 30-40 thousandths bigger. So you can machine a little off where it fits into the housing, but now you have to worry about the OD hitting in the inside of the rotor. Okay, so just make sure if you got the right oil tube material, generally you don't have a problem, but you can increase it. And if you need to, you can actually go in there and actually cut back a little bit of the shaft so your oil tube could go up higher and not hit anything still, and save your oil leak problem. Okay, most of the time it's the holes.
If you're going to switch the tube material, make sure you put a nice polish on that, because the oil, when it's whirl, you don't want it to follow the grooves and start leaking out that way as well.
And that's a fact. He's talking about where we did about 10 Tico motors under warranty, and they have a bolt-in oil tube in there. So on the top bracket, the oil tube has about 6 bolts around the inside at the bottom. You take it off and the oil tube comes right out of it with the O-ring material inside of it. They machined it where it looked like thread cut all the way up the tube. And sure as hell, here come the oil. Right straight up and right over. Okay, filling up the inside of the motor. You want as nice a polish as you can get on it, as clean as you can on the inside of the shaft, as well as the oil tube OD. We're going to switch over now to the actual video that we've made for setting spherical roller bearing.
Vertical motors are often required to handle pump loads that exceed the thrust capacity of angular contact ball-type bearings. Applications employing heavy multi-stage pumps, such as these geothermal wells used to produce electricity, require motors engineered with spherical roller thrust bearings capable of such heavy loads. Spherical roller thrust bearings, running at the speed ranges produced by electric motors, require compression springs to maintain a minimum preloading of this type bearing. This spring preloading prevents smearing damage between the bearing roller and its raceways. Adjusting the spherical roller bearing preload in play requires a different procedure than that used in vertical motors with ball-type thrust bearings. In this tutorial, Reed demonstrates a procedure to set the compression spring preload in play in vertical motors with spherical roller thrust bearings. The spherical roller thrust bearing and springs are part of an assembly located in the upper end of the vertical motor. Here you see the bearing assembly dismantled down to the spherical roller thrust bearing race. The compression springs are located in a cartridge under this bearing race. Here are various examples of different cartridge assemblies with the preload compression springs located within the cartridge assembly. This is what the typical compression springs look like. A significant amount of pressure is obviously required to compress these heavy preload compression springs.
Hi, today I'm going to show you how to set Endplay on a spherical thrust bearing. First, let me show you my rig here. I have our 10-ton crane attached to our spreader bar, which has two large industrial sized chains attached to the motor's lifting ears. Then we're going to need our little bracket here. That way we can put the ram between and compress the springs that are underneath the spherical roller bearing. And just like our previous video on our YouTube channel, you want to use a jack to jack up the shaft. So let's get started. As you can tell, I have my dial indicator set up. That way, when I start to jack up the rotor, I am not going to damage the guide bearing by compressing it too hard against the inner bearing cap.
Warning, warning. If while jacking up the shaft, you see no shaft or dial indicator movement, stop and investigate why there is no shaft movement. You cannot set spring preload in this condition.
So once the needle stops, you know that the guide bearing is touching the inner bearing cap. So next we're going to put on our lock washer and our lock nut. Now this might take a minute because, as you can tell, the motor manufacturer gave me a lot of threads to play with here. All right, next you want to put the bracket over top. Then the ram. All right, and then with the ram, you want to start to compress the springs. But to protect the bearing, what you want to do is you want to watch your dial indicator, because once the needle stops moving, the springs are compressed. If you over compress your spherical thrust bearing, the rollers will actually damage themselves by compressing into the spherical race that's in the housing. So you don't want to go too tight. So you go tight enough, and then when the needle stops, then you know that the springs are compressed. just like so. Then you want to set the dial indicator to 0. Just like so. Then tighten up the lock nut. As you can tell, the difference between the first video and this video is I'm not releasing the jack. I'm only playing with the ram. If you loosen the jack, you're not really accomplishing anything. So the lock nut is tight, we'll release the ram. And as you can tell, the needle didn't even move, so I was too tight. So what we need to do is back the nut off. The tolerances for a spherical thrust bearing is anywhere between 10 to 15 thousandths. You don't want it too tight because you can preload the lower bearing, and you don't want it too loose because you can damage the spherical bearing when they attach it to the pump, and then you'll also do damage on the seals on the pump. So once we adjusted, we check it again. So as you can tell, I'm right on 15. I'm a little picky. I like mine to be on 13. So I'm going to tighten my nut up just a little bit. Recheck it. And there you go. And that's how you set Endplay on a spherical thrust bearing motor. Thank you.
Okay guys, some of the other thinking here is that we've recently gone to STP. I have them now coating the inner race and the rollers just with some gloves on, a small amount, not a lot, dry before we do any of the assembly. And this really does help. When you get the Endplay, a lot of times you can't even turn your carrier without a bar. This makes it a lot easier, believe me. You don't have a bearing running dry on the startup, which is really bad. We've had several motors come in that were brand new that had factory defects in the upper bracket that stopped the bearing from getting the oil. So it took 30 seconds to smoke a bearing. Just starting it up, bam, smoke started pouring out of it. So putting that little bit of film of oil on there, we found that we can now get up there and physically grab the carrier and start turning it, where we couldn't do it before without a 6-foot bar. Okay, so now we're pretty faithful in using that in both lower and upper. So until we have a motor that you could see with, like on the GE or even the US, the bearings are pretty high compared to the oil level going from the sight glass over to the bearing. We stored 5 of the 1500s here, filled them with oil, and turned heaters on as they were requesting and charged them for doing this. Okay, I got up and took the top cover off of it, and the bearing was sticking that far out of the oil. So US is giving people denial on warranties, saying that they're improperly storing bearings because they were rusted. You can fill it full of oil and it's still rust, so they're wrong. But anyway, the STP does help. It makes it a lot easier. You don't soak it, you just put it on with some gloves, wipe it around on it, make it nice and smooth, go to the assembly. Okay, I think once you start doing that, you're going to start probably using that a lot on them. You can use Winds as another product that's the same thing. It's just like STP. So that's one thought. Any questions you can think of?
We have a question here, and again, if you have any questions, you can text 775-433-9390 or email questions@reed-electric.com. So the question here is, any other recommendations for breaking a vacuum in the lower oil reservoir?
We've done a whole bunch of different things here trying to get away from some of the problems. So one, naturally, you could drill a hole and tap it and install one of the little breathers. You could do that on the outside. You could do it on the bearing cap. It just depends on how the housing design is, like on the GE that has the little port for the air to go on to the outside and come through. You wouldn't want to do the bearing cap. You'd want to do out by the sight glass where your oil fills at. Generally there's a nice little square area, And we've gotten very small little 3/8 breathers. They're just designed for airflow, and they got a nice little cap that goes over them. They don't stand this tall, and they're not a real big problem to install. Okay, so that way it'll suck air through the breather. It'll be on top of the chamber, go out through the cap, instead of trying to have that oil pulling out and migrating up. Okay. As far as other breathers, can you think of anything we've done with other breathers methods trying to break?
Bringing out the sight glass tube, coming off with a T, adding a longer sight glass. That way it's more visible, because some of the verticals stand 6 to 8 feet up, and then we'd come off with the other side with another breather. But those are the only two. Good
point. The geothermal people up here, their pump bases are taller than me. So when they set the motor on it, and you know how big your 1500s are or 1250s, you got a sight glass now that they're trying to use a flashlight out there as an operator running by to see if the oil levels. So they've had us install 14-inch sight glasses. On a GE sight glass, when the oil is at the bottom of the sight glass and you can't see it on a 1250, it has 13.5 gallons still in it. At level center point on that same GE is 14 gallons, and it's 15 at the very top, taking to fill that whole chamber up. Okay, so we put those sight glasses on it, and it's made it a lot easier. We actually, even on a few of them, put small little orange balls in the sight glass, so as the oil level went up, they could see that little orange ball easier. Okay, sight glass is about maybe 3/4 of an inch to an inch in diameter, and those also have small vacuum ports on them towards the top. Yep. So we've been able to accommodate different methods doing that. It's a good question. I mean, each motor brand has its own unique headaches, and I know you already know that. So it's kind of a general question what you asked, but I hope we answered it right. Mm-hmm. Any other questions you guys can think of?
The spherical roller bearing, when you're setting Endplay with them, it's really critical that you double check, make sure everything is moving. What I like to do is I like to jack the rotor up and down a couple times, make sure my lower bearing's set right, and make sure that the carrier's not sticking to the shaft. And then when I get my rig all set up, that C channel that you see between the spreader bar and on the carrier, I like to compress the springs and then make sure that you get a full release. Because sometimes, depending on if you did machine work on the shaft right there, if it was tapered, you would know your carrier would get stuck. Those are some of the other things I noticed on setting Endplay on these type of things. And like Jim said before, make sure that you're putting that top oil plate on. That register there keeps it from collapsing that housing.
It's amazing the difference. It's a big difference.
It is a lot tighter. And then on some of the upper housings, when you're doing the machine work on the housings, if you have a cartridge and you're putting a sleeve in, you have to be careful, because that sleeve sometimes will push the cartridge out a little bit, and you have to take a cleanup cut on the outside before putting it back in the housing, or else you'll find yourself trying to beat it in with a hammer. And then on the other housings, for I believe it's a US, it has a spring plate. If you do the machine work on that, sometimes trying to put the spring plate inside that housing, it's really tight. So just take it over to a grinder. It's just there to hold the springs in place. You can just cut the OD of that spring plate and fixes the problem.
Polish it, pretty much. You're not trying to remove heavy metal. All you're trying to do is just free it up to move through the housing. Those are typically a good 1 inch thick. Most of the time you look at your springs and the spring only stick out maybe 1/8 of an inch out of the top of it. Kind of remember the metering plate. We've been making a lot of metering plates to replace metering plates that were bowed real bad, and the outer races have little tits that are raised up all the way around for the bearing contact points. But you'll start seeing them bowed and bent. That's the problem with setting the rotor down, like I was saying, when you're trying to assemble it, not having the jack underneath of it, taking the weight off of it until you get everything else bolted onto it.
We have another question. How do you know what tolerances to use when setting Endplay?
That's a good question. So right off the bat, geothermal customers that we are working with, your group and our group here, they've asked us to set it at 12 to 18. That's the real number, 12 to 18. They have problems with the lower bearings out there growing and expanding. The geothermal world is a lot different. If you can imagine seeing a motor sitting on a pump base and having a cord come off the motor for the power and having a loop in it, and the next day coming after that motor has started up and the well's gotten hot and the loop is now almost straight, that's how much thermal growth has moved in this whole unit. Okay. The bowls for each one of the pumps that you saw, that large pump hanging in the air, has a wear ring that big. So that's how much wear ring that these pumps can move up and down. It's a good 8 inches that it can move real easy, okay, in the thermal area growth. They're pretty sophisticated. They've got all types of sensors on the pump way down in the ground at 2,000 feet that are telling them whether they have vibration, whether they have heat, all types of mechanical wear issues that they're trying to, alleviate. The geothermal world is getting smarter, okay, and they're getting better at their manufacturing their own pumps, and they're counting on us giving them a motor that'll work. So right now the sad thing is they're getting more life out of the pump than they are out of the motor. And it used to be the pump would always die before the motor. So they're dialing this in every day more and more. Okay, so I'm just going to give you a better idea on that. If you've got a bearing that comes in the shop in a vertical and the lower bearing's toast, the odds are there's an Endplay problem.
For the 29 series bearing, for the larger ones, I noticed that they're anywhere between the 15 and 20. The smaller ones are between 10 to 15. So any 29 series bearings, I just would recommend contacting somebody or calling us up and talk about it. And
well, and just like I said, it's brand, gender. A GE in their book says 15 to 20 for the same bearing that's a spherical that's in the GE versus the US, and the US is still hanging at 5 to 10. Okay, so all things being equal, we have the same bearings in both motors, we're using the same everything, but yet the end plays are dramatically different, almost 10 thousandths difference. Okay, and that's a big difference. The geothermal people that we're working with actually contacted General Electric to get them to approve taking one of their motors and increasing the end play, or decreasing the end play in this case. As soon as that pump starts and those springs are up there, and let's say it's not completely collapsed from the weight of the pump, they slap down, and again, you're taking out a very expensive seal when the two faces slap each other coming down. Once they start, they don't shut them off ever unless they have to. But they go on scheduled outages and they have to shut them down and then restart. They don't like it any more than anybody else does, and that's when they start having issues. Okay, so the number 12 to 18 come up based on the net position when we're done setting. You can't always get 12. If your tab's over here and you've got to turn it to get to there, you could go an easy 3 to 4 thousandths easy. So 12 and 4 would be 16, So again, I think that if you're using your own head and you say 15 is an average number, 10 to 15 for the regular everyday motors is probably a pretty good number. Again, the geo people we work with, 12 to 18. Okay. Any other questions you guys can think of?
Maybe you can explain it a little bit better than I on why you have to leave the rotor jacked up and only compress the springs. I didn't really go into a full explanation on why I left the rotor.
So when you jack the rotor up against the bearing cap, and the rotor's, before you even have any hydraulic pressures on the top end, the rotor's up against the bearing cap, so we know that this bearing is now setting here solid. So now all we're dealing with is the upper bearing setting the gap in it, because when we release the jack on the bottom, the bearing is going to be sitting where this 10 thousandths is at, and those springs are going to pull up. So that jack is going to have the bearing sitting right up against the bearing cap until the total weight recommended by the motor manufacturer is on it, which is enough to compress the springs to lower the cap from the bottom bearing, the bearing from the bearing cap itself. So you have to be careful, because if you're not repeating it, that's one mistake. You want to repeat this at least 2 times, 3 times. Get the same number. You're pretty safe then. You want to make sure that that bottom bearing is free floating in there. Otherwise, if it gets cocked, we've seen it over here on the test pad make all types of bing, and all of a sudden everything changes. It can go worse, it could go better. Okay, most of the time it's better. But at that point, you've changed the gap again, and you now need to reset the end play if you hear that. Because you could have added a 5 or 10 thousandths real easy to that number. Okay. If you don't set the jack up proper, you could put too much preload into it, but most likely you will have it too loose.
It doesn't look like we have any other questions.
Okay.
Thank you, everybody.
Thank you, LA. I hope it helps. Good seeing y'all.
Thanks, guys.